Okie doke. Simplifying radicals. Look at number one. What we're looking to do is to, what I refer to as, to be able to find perfect roots. And once we find them, we take the root of them, and they are placed on the outside of the radical. So, what I do is break down the number. What can I multiply together to get 32? Somebody tell me. 4 times 8. I agree. We have to keep going until there are no perfect roots inside. So 4 is a perfect, yes? Okay? But there is a perfect, so I got to bring the 4 over. But there's a perfect in 8. What can I multiply together to get 8? 4 times 2. So now what I have is 2 perfects, and one that's not has to stay inside the radical. So, what is the root of 4? 2. What is the root of 4? 2. And the 2 stays on the inside because it's not perfect and there's not a perfect in it. Now, 2 times 2 is 4 root 2 is my final answer. Now, notice how that took us a couple of steps to get there. The way to not have all of those steps is to divide by perfect roots. So up here at the top, we're going to write that as a note to self to remind us what to do here. Divide by perfect roots. And that's how we're going to get that down to one step. Typing in the calculator much faster than writing all of that out. And it's not wrong to do that. Okay? But this will make it quicker. For instance, look at number 3. Number 3, you want to break that down that much? No. So here's what we do. We have our cards, and that's why I had you staple perfect roots on top, because that's really what we're going to work with. So I've got 552. So when I look at my perfect roots, 552 is not. There's 556 and then 225. So what I'm looking for is the largest perfect root, yes? Because remember, I can find smaller ones, but then there are more in there I have to keep working. So I always start at the larger number. So for 252, I could start dividing by 225 and work my way up. Okay? So we are going to do that, okay, until we catch on that we don't need a number that big. But that's okay. Here we go. So what I do is I've got this sitting here, and I'm dividing by the root. So here we go. I'm starting with 252 and dividing by the 225. Is that a whole number answer? No, so it won't work. So I go up to the next one. So I've got 252 divided by 196. That's definitely not a whole number. And then we just keep going until we find that number. And I'm going to use 144. Still not it. And I keep going. Now, I'm going to skip 100 because I know 100 will not work. I know it won't. Okay, so you can skip if you know it's not going to work. So I'm going to skip that. I'm going to go to 81. still haven't found it. Got about 49. No. What is it? 36 times 7. So, here's what we've got. The root of 36 times 7. And that stays inside the radical. Now, I know it took us a few minutes to type that through, but all of it was pushing buttons, right? So much faster. Now, I know the root of 36 is 6. 7 is not perfect, and it doesn't have a perfect in it, so it stays inside. And that's how we simplify these radicals. But that's why knowing what they are makes it faster for you. Okay? Or, having them. For instance, look at number 5. What's the answer? There it is. Root of 196 is 14. Very good. All right. Let's look at number 9. So now I'm looking at the root of 384. 384. And I'm going to divide that by perfect roots. Where am I going to start? Well, first of all, I'm looking at 384 is not a perfect root. Okay. I could start at 361. Do I need to start that high? Probably not. So I'm going to start a little lower than that. Okay, so you can start where you want to. I want you to find that. Do that now. Start your dividing and find that perfect root that works. Okay? So you can start wherever you want to. Yeah, 64 times 6. Okay? So you can start wherever you want to. So 64, so this is going to be 64 times 6. What is the root of 64? Thank you. 8. And 6 stays inside. Questions? Look at what you have left over. 2 times 3 is 6. 2 more 3 are perfects, so 6 is always going to stay in the radical. Okay? Yes. Yeah, because you're looking at square roots. Okay? The square root of 64 is 8. There's not one for 6. Okay? Thank you for asking. Any other questions? Okay? I want you to take a moment and get the answer to number 14, please. Take a moment and get the answer to number 14. 343. The root of 343. Take a moment. I'll ask you in a moment. Find the answer. Okay, what did you find that to be? What goes inside the radical? What times what? 49 times 7. I agree. And the root of 49 is 7 root 7. Questions? Okay. Any questions about how to do that? Excellent. Turn to the back. And now let's talk about what if I have variables. All right, we're going to go ahead and write our note to self up here, and then we're going to look and see how it works. Here's our note to self for variables. Okay. For every 2 variables, okay, 2 because it's squared, and squared means 2. So for every 2 variables, 1 is placed outside the radical. Okay? For every 2 variables, 1 is placed outside the radical. It is squared, so we're talking 2, so I need 2 to pull 1 out. So let's look at number 17. Okay? What I want you to do right now is just take care of the number first. Tell me what perfect root times what is 320. Do that now, please. And as soon as you get it, let me know what you got. Oh, you got it? What have you got? Tell me what times what is 320. What? No, it's bigger. 16 times 20. 20 has a perfect root in it. Keep going. That's not it. 64 times 5. Okay? 20, Jaden, is 4 times 5. 4 is perfect. So you have to pull that out. Start at the bottom and work your way up. If you still have a perfect, you haven't gotten the biggest one yet. So if you pick one and it gives you a whole number, okay, that's excellent. But if you've got a perfect in what you've already got, move yourself down because you need a bigger number to divide into to make sure you got it, okay? Okay, that's how we learn. That's excellent. Okay, so now that takes care of the number part, but now let's look at the variables. How many x's do I have here? 4 of them. 1, 2, 3, 4. And I'm just putting the multiplication dots in between there to separate them, okay? And then we also have 4 y's. Okay? So here is how it works. For every 2, I'm going to circle it because it takes 2 to place outside the radical. So I'm circling them by 2's. Okay? So what I wind up with, what is the root of 64? 8. Okay, gotcha. Here is a group of x's. That's 1. And I have another group of x's. That's 2. 2 x's are placed outside the radical. This is 1 y, that's 2 y's. 2 y's are placed outside the radical. What stays inside? The 5. And that's how that is simplified. Take care of the number first, then deal with your variables. Okay? Number 19. Please take care of your number first here, and when you know what to multiply together to get 150 with the highest perfect root, let me know what you got. As soon as you got it, let me know what it is. Times. I agree, Wade. Thank you. 25 times 6. Okay. Then I have 3 x's. 1, 2, 3. And I've got 4 y's. Okay. And no, you will not always have to write them out. If you can, we are doing this, of course, for the first couple of times, right? But then once you get the hang of it, when I'll show you what the deal is, and then you can do what you need to do, right? Always taking care of you. All right, I've got 2 x's here, 2 y's, and 2 y's. Okay, so let's see what we've got. What is the root of 25? 5. How many? I got one group of x's here. Can I remove this one from the radical? Yes or no? There's just one. It has to stay there. Only 2 at a time, remember? I can pull out that y, and there's a second y. You can only remove one group of 2. So what stays inside this time? 6 and the x. The single x. Okay? Questions? 2 variables, because I'm talking squared, and squared means 2. So I've got to have 2 of them to make a group to put it outside. Let's look at number 21, please. All right, so for number 21, what's my perfect square that's in 8? 4 times 2, so 4 is my perfect. And then I have 3 u's, and I have 3 v's. Okay. I know that 4 is my perfect. That's going to be my 2 on the outside. 2 u's here. 2 v's there. So here's what I've got. The root of 4 is 2. I've got one group of u's, one group of v's. What's left inside is the 2, a u, and a v. Questions? Okay. On number 23, find the perfect in 384. Do that now, please. Let me know when you've got it. Everybody should be pushing buttons because I know you cannot do that in your head. Let's go. You got 64 times 6, which is it. Thank you. And I just have M and N. Excellent. The root of 64 is 8. No problem. Is there enough M's to place outside? No. Is there enough N's to place outside? No. So what stays inside? There you go. 6M and N. So you could have enough to place outside, you could not. Okay, I just wanted you to see all the different ways that those work. Questions? Questions over how I found these numbers here? Okay. All right, ladies and gentlemen, that is the basic understanding for simplifying radicals.